An application of integrals is being able to solve vertical motion problems. Just like we were able to solve vertical motion problems using derivatives, we are able to use integrals for vertical motion problems. And let's recall really quick. So here's a problem. A ball is thrown upwards with an initial velocity of 64 feet per second from an initial height of 80 feet. When does the ball hit the ground? So let's recall something really important that is going to help us in this problem. Let's recall the relation between derivatives and motion. All right. S of t gives us our position with respect to time. V of t is the derivative of S of t, which is the velocity, and then acceleration is equal to V prime of t or S double prime of t. So if the relation holds this way, well, the relation should hold backwards as well, all right? We can say the velocity is equal to the integral of acceleration with respect to t, right? And then we can say the position is the integral of velocity with respect to t as well. All right, so we're going to be using this part to solve this problem. All right, so let's see. It's saying that, so what are my two variables? It's position and time. All right, it's asking when, that is referring to time. When does the ball hit the ground? Well, the ball will hit the ground when the height of this ball is 0. All right, so our drawing looks like this. My ball is being thrown up, all right, and it reaches a maximum, and then the ball hits the ground. All right, the height here is 0. All right, and it starts being coming through here. All right, t equals 0, t equals what? All right, when the ball hits the ground, and this is the height. All right, so let's see, how can we start doing this problem? So they're saying that the initial velocity is 64 feet per second. All right, so that means the v of 0 is equal to 64 feet per second. All right, and they're saying that the initial position is 80 feet. All right, the initial height, so S of 0 when time, right, this is time, S of 0 is equal to 80 feet. All right, so we're going to be using this information. All right, so we know that negative 32 is the acceleration due to gravity without air resistance. All right, so we can start with that. We know that acceleration of an object is equal to negative 32. All right, this is the acceleration. All right, well, what is acceleration? Acceleration is nothing but just S double prime of t, and this is equal to negative 32. All right, all right, and we know that S prime of t is equal to the integral of S double prime of t dt. All right, so if we do that, then S prime of t, it's equal, well, what is the integral of S double prime of t? Well, S double prime of t is negative 32 dt. So this gives us that this is equal to, remember, not the variable is t, so this is equal to negative 32 t, all right, plus our constant of integration. That's what S prime of t is equal to. All right, do we know any information for S double prime of t? Remember, this is my general solution. I need to start using the particular one. Well, we know that S prime of t is equal to V of t, and they're telling us that V of 0 was equal to 64. All right, so we can actually use that information. All right, so from here we get that V of t is equal to negative 32t plus c. All right, and we know that v of 0 is equal to 64, so we can say 64 is equal to negative 32 times 0 plus c, and it turns out that c is equal to 64. But hey, now we have the equation for the velocity function with an actual value for c. We can say that the velocity function of this object is equal to negative 32t plus 64. Right, we're not done because they're asking us for position. When is position hitting the ground? That is when position is equal to 0. All right, so then to find position, to find S of t, we need to take the integral of V of t. dt. All right, and what is v of t? Well, hey, we just found v of t, so now we have that s of t is equal to the integral of negative 32t plus 64 dt. All right, and s of t is equal to negative 32 is a constant, hold it, t to the second power over 2 plus 64t plus my constant of integration. All right, s of t is equal to negative 16t squared plus 64t plus c. Again, we arrive to a general solution. We are not really interested in general solutions. We want a concrete equation, so we're looking for the particular solution. All right, so how do I find the value of c? Well, they also gave me information. They gave me that the initial position was 80 feet. All right, so I can use that fact. So now I can say s of 0, if s of 0 is equal to 80 feet, then I can write that 80 is equal to negative 16 times 0 squared plus 64 times 0 plus c. All of this will go to 0, so c is equal to 80. All right, now I have my final position function. The position function is equal to negative 16t squared plus 64t plus 80. All right, that is the particular solution for that position function. Now we can answer the question, when is the position function equal to 0? All right, so then we say, when is this equal to 0? Negative 16t squared plus 64t plus 80. Well, we go ahead and solve. We end up that t is equal to negative 1 or t is equal to 5. All right, you have to factor it. But remember what t represents. T represents time from the moment that the ball is thrown up. All right, so time cannot be negative. I wish, right? So the only value is that t is equal to 5. All right, at 5 the ball hits the ground. If we substitute 5 here, all right, we get a value of 0. All right, so that's how we can determine when does the ball hit the ground. All right, we can also answer the problem, when does the ball reaches its maximum height. All right, well, this is the maximum height, all right, which happens to be a little maximum, right? A maximum for what? A maximum for the position function. All right, so then you go to your position function, you find the derivative, you set it equal to 0, and then you prove that it is a maximum there. All right, you can also find the acceleration at that particular point. You already have your acceleration, it's constant. All right, so now we can find either position, velocity, or acceleration at any time t, since we are able to find these equations using integration. All right, I hope that this problem was a little bit clear, and that it answers most of your questions. If you have any questions, please comment on it or just email.